Okay, question 4. Meristems can be cultured in growth medium to produce new plants. An experiment was carried out to investigate the effects of 3 different growth media, A, B and C, on the production of shoots by meristems of African violets. 5 meristems were removed and cultured in each medium for a period of 7 weeks. The average number of shoots produced per meristem was recorded at different times during the investigation. And we've got a graph. Okay, so it's a single axis graph, so in a way that's a little bit less than you normally have, but we have 3 lines, so that's what makes it obviously of another level. So we have, I don't know why I've got a little thing in the middle, there we go. I don't know what we're looking at yet in this one. It's pretty straightforward in terms of this. We've got the average number of shoots produced per meristem, time in weeks, and we've got our 3 different growth media. Okay, we have one that is definitely tailing off, A. B and C still look like they're increasing. Okay. Use values from the graph to describe the average number of shoots produced per meristem over the 7-week period in medium A. Okay, so let's find our points. So you're going to start at 0. So we're basically going to say that over the first 5 weeks, it increased to, reading this carefully across, what have we got, 9.2. So from 0 to 9.2 in 5 weeks, and then remained the same. That's it. There's nothing else to that one. So you're literally just looking at 3 points. Your 0, your 5 weeks, and remains the same to 7. Yeah, there's not even massive units in this one. Just make sure you're clear it's weeks and shoots. Calculate the percentage increase in the average number of shoots produced per meristem between week 1 and week 7 in medium B. Now, the first time I looked at this, I thought they were being really horrible, but actually the numbers are not as bad as you think. Okay, so week 1 of B, if we go here, you'll notice it's between 2.2 of the indices and the lines. So you're going to have to take that across, and it is 3.3. This is your start. Okay, this is a percentage change, so it is always the change divided by the start, and then times it by 100. So our start is 3.3. So our end at week 7 is here, again between 2 points. And I was like, I thought, are they being really horrible? But then when you look at it, it's 9.9. So I'm going from 3.3 to 9.9, so that's 6.6. So that is, even without going to calculator, I'm sure you can see 200%. Okay, so not as bad as it looked at first glance. Table 1 below shows the number of shoots produced per meristem in 3 weeks in one of the media. Use information from Table 1 and the graph. State the media in which these meristems were cultured. So what we've got is 5 meristems and the number of shoots produced per meristem. Now over here, you'll notice is the average number of shoots. So all I did was added these up and divided by 5 to get that what we have here is 5.8. And then it says it was at 3 weeks. So go to 3 weeks on the graph, read up, find 5.8. It is very clearly that we're looking at culture B. It's a bit of work. You're back and forward between 2 sets of data, but not too bad. Predict which medium would produce plants with the greatest number of shoots after 9 weeks growth and give a reason for your answer. Now, I had automatically gone for, B because I'd said that B, so I can extrapolate this out. I was like, B is still increasing and it's got the greatest number at 7. You know, so I thought that was perfectly valid and checked the mark scheme and it said yes. In fact, it's exactly what we want for B, that we are already high at 7 and it's still increasing. So at 9 you would expect the same. But they also accepted C. And if we look at C, what we've got for C, can I get a colour that will show up? Maybe that one. Okay, so C is also increasing still. And it might overtake B. So what you should be saying there is C, because it's increasing more rapidly than B. And it does. It's got a steeper curve on it. And it will surpass B. So either of those. I think B is still easier to get because you don't have to compare it to C. If you've said C, you have to then compare it to why that would overtake B. Okay, but either of those are good answers. and I think totally reasonable. Any further experiment, the average number of roots and the average root length at 7 weeks was recorded in each of the media. Results are shown in Table 2. After analysing the results, medium B was used for the commercial production of plants. Use the information in Table 2 to explain why plants cultured in medium B would be best. Okay, so here is medium B. So they produce less meristems, down by 1, but they have a substantially larger root length, definitely than A, and a little bit bigger than C. If you wanted to check, which I did just to make absolutely certain, if I multiply these together at 144, multiply these I get 209, and multiply that I get 204. So I have, in medium B, the greatest root length on a plant. Okay, so that will get you the first mark, that you're saying that overall they have the greater root length than A or C. And then you have to say, but it says explain why. So why does having a greater root length actually help? Okay, so what are roots for? Roots are for absorbing water and nutrients from the soil. There's your answer. Okay, so if you said that you got more water for, you have to say why, for photosynthesis, or if you said that there was more nutrients for anything you could use that for, so for protein production, because normally we're talking nitrogen, so amino acids. So you had to work quite hard for the 2 marks, to be honest. The first one was okay, you were just saying it has the largest root length, but then for the explanation you had to link the root length to absorption of something and then see what that was for. So absorption of water for photosynthesis, or absorption of nutrients for production of amino acids or proteins. Okay. Can't decide whether I like that question or not, but you know, it's one of your data handling ones, and that's that one done.